Hello, welcome. This is a video detailing how to find different binomial probabilities on the TI-84 calculator. And we'll start with a scenario here for this video. You can see the scenario up at the top here. It says the player of a board game must roll at least 3 5s and 6s when rolling 6 six-sided dice in order to win this particular board game. This is a common mechanic that I find in a lot of board games. It's a mechanic that I'm very familiar with, and that I use a lot when I play these games. So let's analyze this a little bit. First off, we need to verify that these are indeed Bernoulli trials. And if you think about each six-sided die, the probability of getting a 5 or 6 on that die stays at a constant 1/3. In addition, each die is independent from each other die, so that probability is not going to be changing at all, which means that indeed these are Bernoulli trials. We're looking at a sequence of 6 Bernoulli trials, and we want at least 3 successes where the probability of success is equal to 1/3. So we can absolutely use our calculators to find this. This is indeed very useful. Just like with normal CDF and normal PDF, which was our last video, we're going to go into this distribution menu first. To find the binomial probabilities, I find that it's a lot easier to scroll up rather than to scroll down, and you can see third from last here we have the binomial PDF and the binomial CDF. Just like with the normal functions, PDF is going to find us the height of the function, and CDF finds us a range, an area. Unlike the normal model, the binomial model, though, is discrete. So if we want to find the probability that we get exactly 3 5s and 6s on 6 rolls of six-sided dice, we can do that using this binomial PDF. So let's go ahead and do that first. So we get 3 options. There's trials, there's P, and there's an X value. Trials is going to be the total number of trials that we have. That's 6 because we're rolling 6 dice. P is, of course, the probability of success. That's going to be 1/3. And you can absolutely put that in as a fraction. And an X value. For the binomial PDF function, this is just going to be 1 value. So let's go ahead and start with 3, because if we're looking at least 3 5s and 6s, then 3 is one of those possibilities. We can go ahead and paste that and press enter, and we can see that our total is about 0.2195, and that's for the probability that X is equal to 3. Where X is approximately binomial with n trials, 6 trials, and a probability of success of 1/3. So I'm just writing this down as we go so that we can keep track of these different numbers. Of course, 3 is not the only way that we can win this. We can also win by winning by having 4 successes on our sequence of 6 dice. So we go back into our distribution menu, go back to binomial PDF, and all we need to do is change this X value to be a 4. And that gives us 0.0823 is equal to the probability that X is equal to 4. And of course we can continue doing this. We can find I'm actually just going to go ahead and do a shortcut here. You can press second entry to get what you, or second enter, which is down here, to get what you had last. And if you're comfortable doing this without the tooltips, you can go ahead and edit this directly. It's N, P, and then the value that you're looking for. So we can change that 4 to a 5. And we'll get the probability that X is equal to 5. That's 0.0165. That's equal to the probability that X is equal to 5. And then last one, we're going to change that to a 6. and that's 0.0014. It's the probability that x is equal to 6. So now that we have all these written down, what we can do is we can just add them all up, because if I'm looking for the probability that we get at least 3 successes, then I can either get 3 successes or 4 successes or 5 successes or 6 successes. Any one of those is going to be just fine. So let's go ahead and add those up. We get 0.0014 plus 0.0165 plus 0.0823 plus 0.2195, and that will give us a grand total, the probability that x is greater than or equal to 3 is equal to 0.3197. So that's one way that we can solve this problem. Of course, CDF stands for the same thing that it does with the normal distribution. It stands for cumulative distribution function. And if we're looking at the cumulative distribution function, that means that we're looking at a range of values. And we have here exactly that. We have a range of values. So let's go ahead and learn how to use the CDF function as well. Before we do this, it's a good idea to have an idea of what the binomial function or what the binomial distribution looks like. And here it is. Here's the probability that we get exactly no successes. Here's the probability that we get exactly 1 success, and 2 success, and 3 successes, 4 successes, 5 successes, and 6 successes. With this picture in mind, you can see that if we want at least 3 successes, 0, 1, 2, 3, we want to find the area that those 4 bars take up. The trick with the binomial CDF function, though, is that it will only find areas that are less than or equal to. So we cannot find directly the area underneath these bars where x is greater than or equal to 3, where our number of successes is bigger than or equal to 3. We need to be looking at the complement of that, okay, which is the probability that x is less than or equal to 2. We need to find the height or the areas underneath these 3 bars, and then we'll simply subtract that from 1 in order to find the probability that x is greater than or equal to 3. Because those 2 events are complementary, they have to add up to get 1. So I'm going to go ahead and quit back to my home screen. And I'm going to go back into the distribution menu. I'm going to go back up to get to binomial CDF. It's a different function, so we have to re-enter all of our numbers. We're looking at 6 trials with a probability of success of 1/3. And this x value is going to be our upper bound. And we're going to be looking for the probability that our x is always less than or equal to this bound. We can only find probabilities that are to the left using this function. So I'm going to put in 2 for my x value. And we get 68.04%. So let's go ahead and write that down. That's 0.6804. And if we subtract that from 1, we should get the probability that x is greater than or equal to 3. So 1 minus 0.6804 will give us 0.3196, which doesn't exactly agree with what we had before, but that's because I was rounding up here. So the difference here is just in rounding error. Since you waited this long through the video, I want to show you one more thing that's going to be helpful to you. Because I will be asking you on your test to find these probabilities without using either the binomial PDF or the binomial CDF command, which means that you're going to be having to show me your work. But this extra function will find your binomial coefficient for you. That's your 6 choose 3 or 6 choose 4. It's under your math menu. Scroll over to probability, and we're looking for this NCR. Now, when I paste this down into my main screen, you'll notice that it actually automatically takes the answer. So clear that out. If we want to find, say, 6 choose 3, then we're going to press 6, and then we're going into our math menu, choose that NCR, and then press 3 for 6 choose 3, and of course we get 20, which is the same as what we would get using the equation for that. That's the entire video. Thanks for watching all the way to the end. I'll see you next time. Bye-bye.